Hello, this is Mr. Kenzie's integrated algebra class, day 1 of graphing quadratics. We're talking the parts of a quadratic today. This unit should be majority review. So we're taking a look at this first page. This first page talks about the parts of a parabola. All right, the first thing we have is standard form. So we have a quadratic, as we talked about the last few chapters. We have to make sure it's in standard form. What standard form is just decreasing exponent value. All right, so we have y is equal to ax squared plus bx plus c. So now the first thing, we have these two quadratics to state if it's a maximum or a minimum. If the a value is positive, then it will be a minimum, which means it's this lowest point on the graph. So if I take a look here, this one has an a value that's positive. This point would be its minimum. If it's negative, then it would be a maximum. We have a maximum point, which would be right here. The maximum point on this parabola, all right, because the a value is negative. The next thing we have is the axis of symmetry. The axis of symmetry is the line that divides the parabola in half. It is negative b all over 2a. So the axis of symmetry, for review, is this line, this imaginary line that you can fold the parabola in half. And it goes through the maximum or minimum, also known as the turning point. This is the turning point. It's where the parabola changes directions. The domain are the x values. This will be written like so. You will have some number here less than or equal to x, which is less than or equal to then another number. It goes from smallest to largest, and this is always the x values. Next thing we're going to do is we're going to take a look at a couple of these examples. So looking at number 1, we have y is equal to x squared minus 6x plus 8. The first thing we want to do is we want to sketch the graph. Now, because our a value is positive, I know that my graph is just going to look like this. So that's just the sketch that I want. Will this be a maximum or a minimum? Well, because the a value is positive, the a value once again is the number in front of x squared. Okay, this is going to be a minimum. And what is the axis of symmetry? Well, the axis of symmetry, we're going to use this formula. X is equal to negative b all over 2a. So we have x is equal to negative, the b value, all right, is the number attached to x, which is negative 6, all over 2 times a, which is 1. So we're going to simplify that. Negative of a negative 6 is positive 6. All over 2 times 1, which is 2. Therefore, our axis of symmetry for this one would be x is equal to 3. The next part says we're going to find our values. So our values for this, okay, are going to be starting off with the axis of symmetry. So when x is equal to 3, and now we're going to take 3 or 4 values to the left and the right. So the largest, obviously, 4, 5, 6, and 7. The 4 that are less than are 2, 1, 0, and negative 1. All right, so those are all the values that we're going to include in our domain. Now to write this, we're going to take our smallest value. Our smallest value is negative 1. And our largest value that we're going to use is 7. We then put an x in the middle. And we want this to be less than or equal to on either side. So that right there is our domain. So again, the domain is the x values. All right, this comes from a table. Now, if we were going to graph this, our table would be x and y. We would take all of these x values, which are from negative 1 to 7. So negative 1, 0, 1, 2, 3, 4, 5, 6, and 7. So that's a table that we would use. Our turning point is the combination of our axis of symmetry and the corresponding y value. Once again, the turning point is where it changes direction. Now we can do that by hand, but we can also use our calculator. So to use our calculator, I'm going to go take our calculator out. I'm going to go to y equals. All right, so for y equals, we have, and I'm going to type in the equation, which is x squared minus 6x plus 8. Now, when we graph this, you'll be able to see that this will be a parabola across the x-axis, 2 spots. But we want to get the y value, so I'm going to push second graph. And the y values that I'm going to use are going to be where there's repetition. So I got to kind of scroll down and use the ones that we had in question D. And I'm going to copy down the y values from -1 all the way to 7. So I'm going to copy down 15, 8, 3, 0, -1, and so on. So we're going to go over here, and we're going to copy this down. So we have 15, 8, 3, 2 is 0, -1, 4 is 0, and they repeat, as you know a parabola does. So our turning point, we would represent this, and I'm just going to show this here. It doesn't specifically ask for it, but you will be asked to do that in future lessons. So our turning point we take, which is the axis of symmetry, the x, and the corresponding y value, which is like so. You are going to do the same thing over here for number 2 as part of your homework for tonight. Please take a look at the next page. Now we're going to graph this. It says graph and label the function f of x. F of x is just functional notation, and it's x squared minus x plus 5. Where it says f of x is equal to y, well, we know from functional notation earlier in the year and in previous years that f of x just means y. The first thing that we always need to do is we need to find our axis of symmetry. And our axis of symmetry is once again the line that divides the parabola in half. So I'm going to take this equation and I'm going to plug in and find the axis of symmetry. Now the axis of symmetry formula is x is equal to -b all over 2a. So I'm going to plug this in just like so, using parentheses. And I'm going to replace the b value with a -1 because that's in front of here. It might help you to write out what your a, b, and c values are. So we have a is equal to 1, b is equal to -1, and c is equal to 5. So our b value, once again, is -1. A value is 1. Now this one is an important example. We have negative of -1, which is +1, over 2 times 1, which is 2. We have an axis of symmetry that is a 1/2. So in that case, we're going to have to find our turning point by hand. So I have x and y. Now the values that I'm going to use, we're going to put 1/2 in the middle. And then we're going to take however many values that will fit on the graph. I'm going to try to put 4 just to keep it consistent. So 4 values that are less than. Well, the first value that's less than 1/2 would be 0. Then we'll have -1, -2, and -3. Now we need 4 values that are greater than. So 1, 2, 3, and 4. To find the turning point by hand, I'm going to take this 1/2 and I'm going to plug it into the equation. So we're basically doing f of 1/2. I'm going to plug 1/2 in right here for x squared. So we have 1/2 squared minus 1/2 plus 5. Now I'm going to use my calculator to kind of simplify this for me. Make sure when you do that to use parentheses. So I'm going to go back over here to the calculator. And I'm going to type it in exactly as I just wrote it. So I have parentheses 1/2 so parentheses 1 divided by 2, close parentheses squared, minus 1 divided by 2, close parentheses, plus 5. All right, looks just like that. I'm going to push enter, and I'm going to get a y value of 4.75. That 4.75 is the corresponding y value. So I'm going to put that right here, 4.75. The other values I'm going to get are going to be right from the calculator. So I'm going to go back to y equals, and I'm going to type in the original equation, which is x squared minus x plus 5. So you can look at the graph. A value is positive, so you have a minimum. Push second graph. And now, if you look here, see how in between numbers 0 and 1, 5 and 5, there's no middle. Now, we know by looking at the picture that there was a clear-cut turning point. We got that by hand. So I'm going to copy down the other values from -3 all the way to 4. So I'm going to take my paper, I'm going to copy those down. So we have 17, 11, 7, 5. We already filled that in because we found it by hand. 5, 7, 11, and 17. Now you only need the values that fill up the graph, or that fit on the graph, I should say. Okay, so really the only thing that I'll be graphing is from -1 to 2. Because those are the only ones that'll fit. So I have -1 and up to 7. I have 0, 5. Now I have 1/2, which is an approximate in between 0 and 1. I'm going to go up 4.75, which is about right there. Then I have 1, 5, and 2, 7. So our parabola would look something like this. Now, right after the last point, put your arrows. We're going to label this f of x is equal to x squared minus x plus 5. Now, the next thing that we are going to do is we are going to answer a couple questions. What is the turning point? Well, we know we found the turning point by hand. It is 1/2 or 0.5, comma, 4.75. The next part is the turning point a maximum or minimum. A value is positive, so we have a minimum because it can go no lower than this point. So I'm just going to circle minimum. Now it says describe the roots. This is going back to last chapter. Looking at this graph, it does not cross the x-axis. So because it does not cross the x-axis, our roots are imaginary roots. So really today, you only have to finish one question. You might want to get started on the next page to kind of help yourself out. Thank you.